there guys, this is Mr. Herbst here, and today our focus is going to be on energy flow. So we're going to talk about in this video food chains, food webs, and ecological pyramids. Now, the first thing I kind of want to lay down here is, where does all of the energy for life come from? Well, if you think about it, it actually all comes from the sun. The sun is the main source of energy on Earth. Now, of course, there are some organisms that have to depend on other organisms for their energy. So there are some organisms that, of course, eat other animals or other organisms for their energy, but as the whole food chain, it all comes down to plants. Plants make energy from the sun. And so those organisms that eat other organisms eventually are ones that eat plants. And so therefore, if the sun wasn't there, there would be no life on Earth. The organisms that can use the sun for their energy are called producers. They are also called autotrophs. So these two words right here are going to be interchangeable in our entire unit. Producers, aka autotrophs. Those are organisms that can capture sunlight and use that as energy. Because they make their own food, once again, they're also called producers. And here's a few examples of producers. If you look on land, there are all sorts of plants that live on the land, and so autotrophs that live on the land are the dominant land source of autotrophs. However, though, in the ocean and in lakes and streams, there are autotrophs that you might have not heard of or might not think of too much called algae. Algae is a photosynthetic organism capable of using the sun's energy for food. And then finally, also, there are some certain kinds of bacteria that are really crucial for a lot of different ecosystems that can use the sun's energy for food. Now, organisms that use other organisms' energy are called consumers. So the organisms that cannot directly make their own energy from the sun are called consumers. Those organisms, of course, rely on other organisms for their energy, and thus they are called heterotrophs. So I'm going to go ahead and underline heterotrophs here, and I'm going to put an arrow because these two words right here are interchangeable during our unit. So heterotrophs are also called consumers. Now we have 5 major types of consumers. The first kind is the herbivores. Herbivores are examples like this tortoise over here, where he's eating nothing but plants, or this gazelle eats different kinds of grasses and other kinds of plants. And then also insects also rely on leaves and plants for their food. That is the opposite of carnivores. Carnivores are organisms that eat meat. Such as, a lion has to eat its meat, a shark eats meat, and of course a wolf relies on meat for its food source. They don't really ever eat any plant-based sources. However, there are some organisms out there called omnivores that are capable of eating both plant and animal sources. It's pretty cool. For example, the biggest omnivore on Earth, the current animal that is dominating Earth that is an omnivore, is the human being. Human beings can eat pretty much anything. We are omnivores. We can eat plant and animal-based foods. Other examples of omnivores, and this is one that is a common misconception, but bears. Right down here, this picture is of bears. Bears are omnivores. Now, I know a lot of people think of bears as being carnivores because they see them eating salmon or other small animals. But actually, bears spend a lot of their time picking berries and eating certain kinds of plants. They spend actually less time eating animals than they do eating plants. And finally, another example of omnivores is organisms that are related to us, gorillas and other types of apes. Then, there are these organisms called detritivores. They are not super well known, but they are organisms that are capable of eating basically dead stuff. So slugs or worms. If you ever wondered about what does a worm eat? Well, they basically eat dirt. And so they're basically, on their most basic level, they're getting things out of the dirt. They're getting the nutrients out of the dirt. They don't necessarily, we shouldn't necessarily confuse them with decomposers, because decomposers are things that will actually sort of break down living material. They are things that sort of live on things that we wouldn't really have thought of as food. And finally, the other types of consumers are the decomposers, which I just mentioned. Decomposers, really good examples of those are things like fungi and bacteria, which these things here are capable of breaking down living organisms. They're different than the detritivores in the sense that they actually are capable of breaking down the living organisms. Well, detritivores are the things that will actually live on stuff that we think of as non-living. All right, here guys, we're going to somewhat switch gears here. We're going to talk about the energy flow of life. Now, energy flows through an ecosystem in one direction. Now, if you think about it, that direction all has to start with the sun. And then from the sun, we talk about autotrophs, which are capable of producing energy from the sun, and then also to heterotrophs. So it flows in one direction, from basically the bottom up. And when we talk about energy flow, we like to talk about something called a food chain, which is a series of steps which organisms transfer energy by eating or being eaten. Here's an example of a food chain. Let's say that we're talking about a food chain of the ocean. It all starts here with algae. That algae is going to take some of its energy and going to be eaten by plankton. So plankton is going to eat algae, and then the small fish are going to eat plankton, and so the energy is going to get transferred over to the small fish, and then the squid or other bigger fish are going to eat small fish. The energy is going to get transferred over to the squid, and then finally the shark is going to just munch up everything and all the animals it can eat, because it's at the top of its food chain. So if you think about it like this, a shark would not be able to exist unless there was this organism such as algae that was able to produce all of that food. And so my question to you guys is, what does the arrows in that food chain actually mean? So going back to this right here, what do these arrows actually mean? Well, those arrows indicate which direction the energy is being transferred from one organism to the next. And now we like to talk about those links in the food chain in sort of sense as if you can't have a whole lot of them. Most food chains actually have no more than, say, 5 of those links. And that happens because by the time you get to a 5th link, there's really only a small amount of energy that's actually capable of being absorbed by the organism. And so that happens because most of the energy, or a large portion of the energy, is lost as heat. Now you can think about it like this. Let's say that a rabbit eats grass. Is 100% of the energy in the grass going to be used by the rabbit? The answer is no. The rabbit is a warm-blooded organism. It has to keep its body temperature up. And so by eating all that grass, it's going to burn that food as fuel and keep that body temperature. So that brings me to my next concept, where we talk about a food web. A food web is sort of like a whole relationship of an ecosystem and all the networks of a food web combined. So we're not just talking about one food chain, we're talking about many food chains if we talk about a food web. And it links basically all the food chains in an ecosystem together. And it is more detailed and more of a real-life example. A food web is a real-life example of how the transfer of energy in an ecosystem works. Now, one thing that's kind of important to understand here, guys, is these things called trophic levels. Each organism in a food chain represents what we call a feeding step, or AKA a trophic level. Producers make up the first step of the level, and then consumers make up the second, and then finally there are consumers that also are capable of eating other consumers. So each consumer depends on the trophic level below it. So organisms that may, say like a wolf that eats rabbits, are going to are going to depend on the consumers that eat plants, and rabbits are going to depend on the producers that make energy from the sun. And so there's sort of this ecological pyramid that shows the relative amount of energy at each trophic level. So let's say that we start here. I'm going to go ahead and draw an arrow down here. Let's say that, for example, we talk about this energy coming from the sun. And we talk about energy coming from the sun. We like to talk about it in forms of joules. Joules is a measurement of energy. It's a physics term. Basically, anything that is moving has joules of energy. However, let's say that we have 1,000,000 joules of sunlight. When those plants photosynthesize all of that stuff, all the sun's rays, they are going to use only about 1/10 of that. And so only about maybe 1/10 of all of the energy is going to get transferred from the sun into plants. And so we're going to start out with 1,000,000 joules of energy, but then we're only going to go to 10,000. And then there's going to be organisms that eat those plants, such as insects, and then we're going to only be left with 1,000 joules of energy. And there's going to be organisms that eat those insects, such as mice or other small animals, and then we're going to only be left with 100. And there's going to be organisms that eat those small animals, such as eagles, and then we're only going to be left with 10 joules of energy. So guess what? Here's what I'm showing you here, guys, is that as the food pyramid continues, a lot of energy is lost. And once again, that energy is lost in the form of heat, primarily. And so one thing I want to make sure that we're clear about is the more levels that exist in between a producer and the top level consumer. So the more levels that exist in an ecosystem, the less energy that remains at the original amount. For example, let's go back in here. We talk about 1,000,000 going to 10,000, going to 1,000, going to 100, going to 10. But what about at its most basic level, what if we say humans are going to eat this bird right here? How much of the energy are humans going to get? Well, if you follow the trend, humans are only going to get 1 joule of energy. Anyway, here, guys, it's going to conclude our little video on energy flow. This is Mr. Herbst here. Make sure you complete the Google form below. It's going to contain those questions that are in your notes. If you're in Stride Biology, once again, we're going to talk about those questions in class. I'm signing off, folks. You all have a nice day.